Hello everyone. Good morning, good afternoon, good evening, depending on where you are joining us from. Welcome to yet another webinar on Kubernetes series. And this time I'm very excited to bring scaling and managing deployments in Kubernetes. So for those of you who are attending this for the first time, my name is Janaki Ram, based out of Hyderabad, India. I'm a Google developer expert focused on Google Container Engine and Google Compute Engine. I'm also a CNCF ambassador, which is the Cloud Native Computing Foundation's ambassador, where I actively evangelize Kubernetes and associated projects to developers. So this webinar series is a monthly webinar series where we bring the concepts of Kubernetes one at a time. For the last 8 or 9 months, we have been covering a variety of topics. And those of you who have been following us know that each webinar focuses on one specific aspect of Kubernetes and digs deep into it. All these webinars are recorded, and the slides as well as the videos are available on YouTube and SlideShare. So let's get started. And I want to make sure all of you are able to follow this webinar, both the audio and video. So if you have any questions or if you have any issues that you need to report, feel free to type in the questions window, and I'm keeping an eye on that. All right, so let's get started. So what are deployments in Kubernetes? So before that, we need to understand the replica set concept. If you're already familiar with replication controllers, you'll find replica sets very familiar. So I'm going to spend a minute explaining you what is a replica set and how deployments are dependent on that. And then we'll take a closer look at understanding deployments and look at some of the aspects like use cases, the benefits, and why you should switch to deployments for running your workloads in Kubernetes. I have a few fun demos like every time, and hopefully all of them will work because I have some issues with my local cluster. So hopefully I'll be able to show you all those fun demos that I created. So without further ado, let's get started. So replication controllers are one of my favorite topics in Kubernetes because it lets you quickly scale your pods to any number of application deployments. So if you have packaged your container as a pod and you want to make sure that there are at least 2 pods running all the time within the cluster, the best practice has been to use a replication controller. And in fact, you should avoid deploying a pod directly and always package it as a replication controller, because it will ensure that you at least have 1 pod running all the time. And replication controllers are wired to a service, and the service basically uses the label selectors to match the backend pods and expose them to an endpoint. But replica sets are slightly different. So replica sets are exactly like replication controllers, but they are considered to be the next generation, primarily because they support what is called as set-based selectors. So the fundamental difference between a replica set and a replication controller is the way they are associated with the pod definition. So in a typical replication controller, you use an equality operator or an inequality operator. You'll always say my pod should match a specific value, or it shouldn't match a specific value. Whereas a replica set is far more sophisticated, and you can use more complex expressions to match the pods. Here on the slide, you'll actually see that when we are creating a replica set, we're actually saying the component is Redis, and the tier has to be in cache, but it should not be in dev environment. So this is much more sophisticated and much more complex. So you can use a variety of operators and have a very fine-grained way of selecting your pods that participate in the replica set. So Kubernetes community favors replica sets instead of replication controllers because of this feature. And eventually, they will become the de facto way to scale pods. And as the selectors become more and more mainstream, replica sets will be the way forward for scaling the pods. So having set the stage for deployments through replica sets, let's understand what are deployments. Kubernetes is already very simple. If you are familiar with Kubernetes, you know that there are multiple objects, API objects like pod, a service, replica set, a replication controller, and so on. So you can typically take a container, package it as a pod, deploy it, and then scale it through a replica set, and then use a service to expose it. And this is the workflow that most of us follow. But there are certain challenges with managing plain vanilla replica sets or a set of pods. What if you need to upgrade the image of all the running pods with one command? And what happens if that upgrade fails and you need to roll back? And how do you ensure that you pause the rollout and you ensure that 50% of your pods are running version 1 and 50% of your pods are running version 2, and you can selectively track how the traffic pattern is and which one the customers like, which are typically called as canary deployments. So performing those operations on replica sets and replication controllers is not easy. So to bring those capabilities to Kubernetes workloads, we have deployments. And what I personally like about deployments is the fact that it is basically a PaaS-like environment on top of Kubernetes. So if you have ever used a platform as a service layer like Heroku or Google App Engine or Azure's App Service, you know how it basically works. You take your code, you package it, you deploy it, and then you scale, and you upgrade, you roll back, you perform rolling upgrades, and you have a complete track record of how the deployment has been so far. So that is a typical PaaS experience used by some of the offerings like OpenShift, Cloud Foundry, Heroku, Apprenda, and so on. In a lot of ways, deployments basically bring PaaS-like abilities to Kubernetes, giving the developers the same mechanism and the same workflow of deploying workloads. So one of the biggest advantages of using a deployment versus a set of pods and replica sets is that you can define the desired state of your application. You can actually say that my application needs to run at least these many instances, and out of this, these many should be running a different version, and the remaining pods should be running another version. So you can basically state the configuration, and Kubernetes will ensure that your entire state of application is maintained like the way you declared it. So deployments will ensure that the cluster maintains the desired state of application all the time. As I mentioned, replication controllers and replica sets fall short of key requirements that you need to manage application deployments and treat Kubernetes like a PaaS layer. So deployment object brings tremendous flexibility for managing and scaling applications in Kubernetes. This will be much more clearer when I show you the demo. So why use deployments? I already touched upon it, but some of the operations that you can perform and the typical workflow includes creating a deployment, which means you deploy an app, which is a collection of containers. You then update a deployment where you roll out a new version. So you basically replace the image of all the running pods with a new version. You can perform rolling updates. So this ensures there is zero downtime during your upgrades. This is one of the very powerful concepts of deployments. So let's say you have 10 replica sets running V1 and you roll out V2. At any point of time, you have some pods of either version running. So some of the pods will continue to run V1 while there is a rolling upgrade that takes place eventually replacing all V1 pods with V2. So this will give you a very sophisticated, staggering upgrades instead of killing all the pods and then deploying a new version. So that delivers a very graceful way of upgrading applications with zero downtime. And in case you face an issue and there is some problem with the latest version, with one command you can roll back and take your deployment to the previous state. You can also pause and resume a deployment. This is where you can basically have a canary deployment coming into Kubernetes. So you can actually push a different version, then pause the deployment and monitor the user experience feedback, and based on how your application is faring, you can decide to completely replace the previous version with the new version. So those are some of the capabilities of deployments. So the use cases, it's pretty straightforward. Create a deployment to bring up a replica set and a collection of pods. You check the status of deployment to constantly see what is the status, what is the current state of your application. You can update and recreate pods. You can roll back. You can pause and resume, as I mentioned earlier. So taking a closer look at deployments, as I mentioned, deployment is a Kubernetes object. It is very similar to a pod or a service or a replica set or any other object that you deal with in the Kubernetes environment. So this is still in beta. That's the reason why you actually see app/v1 beta 1. Kind is deployment. Instead of a pod or a service, you start with a deployment. There is metadata, which is a mandatory section where you update the name and additional metadata applicable to the object, and then you define the spec. The spec is nothing but a replica set. So you define how many replicas you need, and then you get into the template where you actually have the metadata followed by spec. And spec is where you actually have the container definition. So in this sample that we are seeing, we're actually rolling out Nginx. So once you create the deployment definition, you basically use the kubectl to deploy it, and then get deployments to check what is the desired state, what is the current state, and how many of them are up to date, and how many of them are available. Each of those sections have significance, and they actually convey something during a live deployment, so which we'll understand more when we actually see. So kubectl set image deployment is a way to update your existing deployment. So we are now replacing Nginx 1.7.9 with 1.9.1. And right after executing that command, you can actually see the status with the kubectl rollout status, and that will tell you how many are rolled out and how many are pending. So in this example, we are seeing 2 out of 3 new replicas have been updated. So this is the typical workflow that you follow for deployments, and I can't wait to show you some demos. So it's time for me to switch to my terminal window and show you a couple of demos. So I hope you're able to follow the entire session, and the audio and video is clear. If you have any issues, do let us know by typing in the chat window or in the questions window. All right. So I want to show you a very simple use case as an end user. So this is how you would actually see an application running in the browser. So this has nothing to do with a techie demo, right? So I want to show you how we can actually use Kubernetes deployments to deliver better experience to users. So on the right side of my screen, you have a browser window, and on the left side, I have my command center from where I'm going to control Kubernetes deployment. So what I'm going to do now is actually launch a simple application, right? So I want to pin them here. So let me roll this out. So I'm running a simple application called update demo. And what it basically does is it actually shows us the number of pods running in the current environment. So the moment I execute this command, you see that there is a pod that's created. So when you check with kubectl get pods, you will notice that of course there are some pods from my previous demo. Let me actually get rid of them. So kubectls delete deployment hello. This will get rid of some of the other pods that we don't need to see at this point. So now when we actually do kubectl get pods, some of them are terminating, but we actually see that one pod is running from our update demo. So now what I'm going to do is to go ahead and scale the deployment to multiple replicas. So all right, so let's keep this here. And when I scale this to 4 replicas, we'll see the browser creating additional pods and visually showing them here. So now you notice that we have 4 pods that are running. So now it's time for us to do an upgrade. So currently you see a different image here. It's showing a Nautilus kind of an image. So now I'm going to update this with a kitten. So what I'm going to do is simply edit my deployment with this command called kubectl edit. So now I'm going to open the default editor and replace the image with kitten. So let me make sure it is the exact one. Okay, and I'm going to save this, and immediately my pods get updated. So now what actually happened is while the application is running, we have gone ahead and upgraded that from showing a Nautilus to a kitten. So this is how deployments work, where you can actually take control of a running application. That's not all. Now I can actually undo the previous deployment, which is basically going back from kittens to the previous one. So now when I actually do a rollback, you'll notice that all the current kittens get replaced by a different image, and now we have rolled back the application. So it's also possible for me to basically pause the rollout and make sure that some of the pods are showing the kitten and some of the pods are showing the other image. So it's pretty easy to manage these applications. So this is the experience that end users would get. But again, I haven't really started explaining you what it takes to create a deployment and how you apply that to your application. So before we go any further, let me get rid of this deployment. So I'm going to delete this deployment called update demo, and my cluster should be, yeah. The moment I delete, you notice that the browser is completely blank. So that was the first demo where we ran an application with a replica set, and while it is still running, we upgraded and then we rolled back. So that was the first demo. Now I want to show you a slightly more insightful demo where you can understand and relate how you can apply this to your production workloads running on Kubernetes. So for this, I want to show you my first deployment. So here, this is the extensions v1 beta 1, which is the YAML definition of a deployment. Kind is deployment. And then I have this deployment called jhello, which is pulling an image that simply says hello world. And I have multiple versions of this image to print hello world v1, v2, v3, and so on. So this image is going to run as 3 replicas. So as you notice, the deployment is nothing but a collection of a replica set as well as pods. Basically, it's a uber definition for a replica set with many more capabilities that the standalone replica set may not give. But apart from the first few lines, everything else is almost like a replica set. It's not very different. So that's the deployment object. And then this is my service. So I'm exposing these set of pods as a node port, which is going to be available on port 30,001. So it's a simple hello world deployment available to us through a service endpoint, which is going to be listening on 30,001 port. Excellent. So now that we know how to define a deployment and how it actually looks like, it's time for us to go ahead and take a closer look at it. So the very first step that I'm going to do is to deploy my artifacts, which is basically the deployment definition and the service definition. So looks like we already have the service. So now when I actually type kubectl get pods, you notice that there are 3 pods. We'll come back and take a closer look at, and when you look at the get services command, you see that there is a service called jhello, which is available to us on port 30,001. So far, so good. It is very straightforward. Now, when you use this command called kubectl get deployments, you notice that this has desired, current, up to date, and available. So desired is what you actually define in your YAML definition. So in my YAML, I said at any given point of time, I need 3 replicas. That's what desired translates to. Current is how many of those are currently running, whether desired matches current or not. In some cases, this could be less than the desired or more than the desired. But the goal of a deployment is to make sure that the desired and current is always in sync. Up to date is a parameter which will ensure that the current pods are based on the image that you defined here. It may happen that the current number of pods are 5, desired is also 5, but up to date are only 3 because the remaining 2 are basically pulling the latest image. So up to date will ensure that all the current pods are running version that you defined in your deployment. Available is a metric that tells you how many of the current pods are actually available, which means if there is any back off or if there is a container creating status, the number here would be very different. So it may happen that the current number of pods would actually match the desired, but they may not be available because they are still either getting created or there is an error. They are not actually serving. So available will tell you how many of them are actually functional. So as you notice, this is the key difference between using plain vanilla pods or even replica set. This is the biggest advantage you get when you are running a deployment, right? So you can also use kubectl deployments, which will tell you a lot about your current deployment. So it tells you what is the strategy for doing your updates. Rolling update is with 0 downtime. The other one is actually replace, where there will be some downtime. What is the rolling update strategy? 1 max unavailable, 1 max surge. So this will define the uptime, the availability of your deployment. So this will give you the picture of your current deployment. Now you can also use kubectl get pods with show labels, and you'll actually notice that Kubernetes has gone ahead and added a label called pod template hash is equal to this. So this is how pods are tied to a deployment. So basically every time you roll out a deployment, it is going to create a hash and assigns that hash to every object that is created within the deployment, which means all the pods, all the replica sets will automatically inherit this label, which is pod template hash. And it also gets appended to the actual pod name. So typically when you launch a replication controller or a replica set, you see the pod name followed by an arbitrary random name assigned. Now that remains the same, but in between the random name and the actual definition of the pod, you notice that the hash is getting injected. And this is an indication, and this is how a deployment is associated with the current set of pods. All right, so you can also get the replica sets and look at the labels. So again, this also has the same label, which is pod template hash is something. And again, this is an indication that this replica set belongs to the deployment and it is not a standalone replica set. This will ensure that there is no collision between one deployment and the other. That's the reason why Kubernetes goes ahead and does a hash. We have already seen this service. Let me set this environment variable, which will make it easy for us to access the app. So this is node port 30001. And now let's go ahead and do a curl on our service. So now it shows hello world. So basically I'm running a Node.js Express REST endpoint, and that simply emits hello world, nothing fancy. Now we can go ahead and scale the deployment to 10 replicas. So now this is going to quickly create 10 pods. So again, it's not very different from what you actually do with a replica set. The only difference is now it's a part of a deployment. So very soon you'll see all of them in running mode. So now if you actually do the curl command again, it's hello world because all the pods are running v1. Now I'm going to upgrade to version 2. So I'm going to set the image of deployment jhello, and we are replacing the pod definition, which is what we define here. Actually, the container name is also jhello, with the image which is jhello2, and this is v2 of my application. So now the moment I execute this command, and when we look at the number of pods, you'll see some of them are getting created and some of them are getting terminated. So the reason is it is performing a rolling upgrade where all the v1 are gracefully getting terminated and they are eventually replaced by a v2. In just a few minutes, we should have v2 running across all the pods. And at this point, if any user hits our endpoint, some of them might see v1, some of them might see v2, but there is no downtime. And now all the 10 pods will eventually end up running v2. So we have 3 more pods that are terminating, and now we have just 1. So that's it. So now our upgrade is done. And if I actually do the curl again, now we are on v2. So very simple way of performing an upgrade. All right. So with that, we can also check the history of our deployment rollout. So when I execute this command called kubectl rollout history, it actually tells us there are 2 revisions. The first one was the very first deployment. The second one was an upgrade. So let's say we are not happy with this release and we want to go back to the previous version. So now let's keep this running. So in watch mode, kubectl get pods. So currently we have all the 10 pods running v2. I come back here and now I'm actually doing an undo, which means we are going back in time and applying revision 1 to our deployment. So rollout undo on this, and let's watch the magic. So now, just in a few minutes, we'll again see all the new pods coming up, the older getting terminated, and very soon everything will stabilize on v1. So that's the beauty. At this point, if you hit the service endpoint through the curl command, you might see v2 occasionally, which is fine because pods are stateless and it is okay for us to serve some versions. But at this point, you can basically see how it is upgrading. You can also do a kubectl get deployments, and now you'll actually see that 10 out of 10 are available, they are up to date, and they are current. So at this point, if I do a curl, I consistently get hello world because we have rolled back v2 to v1, and it is as simple as that. This is a phenomenal way of taking control over your deployments. So let's clean up and start another demo. So now I want to get rid of my deployment. The other advantage you have is this one single command will basically get everything cleaned up. So you are basically deleting the entire deployment, and every artifact associated with that will go away with this single command. We can also delete the service that we created earlier. And now at this point, if we do kubectl get pods, everything is terminating, and kubectl get service will show us there are no service except the system Kubernetes one. All right, so that was the first demo where we have basically deployed an app and upgraded that on the fly with zero downtime. Now I want to show you a scenario which is slightly different. It is still based on the same app, which is a Hello World app, but here we are going to actually do a canary deployment. So we'll pause the deployment while it is taking place, and then we will test the deployment, maybe routing 50% of the traffic, getting the user feedback, and once everything is fine, we resume the deployment rollout so that we go ahead and replace all v1 with v2. So let's go ahead and see that in action. So this is another cool demo where we can control how the rollout actually takes place. So we are now running this, and if you see the number of pods, there are 3. It's exactly the same definition as the previous. So now we have 3 pods running, and the deployment will show us, there are 3 desired, 3 current, and everything is up to date. This is perfect. Now let's do a curl on this, and it throws hello world, nothing fancy. This is basically the v1 that we are running. And now it's time for me to scale our application like last time. And now when we actually look at this, it is upgrading. And now let's take a look at this. Okay, so desired is 10, current is 10, up to date is 10, but available are 5, right? So this will indicate that how many of them are actually available. So because we haven't changed the spec, all these 3 will remain the same, and only the availability factor will change. Next time when we actually do a v2 upgrade, then you would notice that the up-to-date parameter also changes. So now at this point, we have successfully scaled our deployment to 10 replicas, and we are still on v1. All right, so now let's check the status. So nothing changes because we are still, sorry, I jumped a little bit. Okay, so now it's time for me to upgrade to v2, right? So now across all the pods that we are running, we are going to replace v1 with v2, and right after that we are going to pause the deployment. So I'm going to hit enter, and now you'll actually see that some pods are terminating, and here the number changes, up to date 4. Now the moment it hits 5, I'm going to pause the deployment. Now when I actually pause the deployment, there is something very interesting. So desired is 10, but there are 11 pods, which means some of them are running v1, some of them are running v2, and we have 6 up to date, which means 6 of them are upgraded and 5 of them are running v1, and that's the reason why there are 11 available, which is the state that I need. I need 50% of the pods running v1 and 50% running v2. So now when we execute this command again, it actually tells us that waiting for rollout to finish, 6 out of 10 new replicas have been updated. So let's leave this, and now let's do the curl again. And this is going to end up giving us either V1 or V2. And this is exactly what I want, because I want to do a canary deployment and see how many users actually like V1 and how many of them like V2. So instead of doing this, I'm going to put this in a loop and have some fun. So every time a different pod is hit, we'll see V2. And because we are running 6 out of 10 in V2, so we'll see about roughly, or rather 6 out of 10 are still running V1. So we are actually seeing 60% of the traffic coming from V1 and 40% from V2. So this is how you can basically route the traffic across different versions and get user feedback, or look at your metrics, look at your logs, and later on you can come back and just execute one command, which is kubectl rollout resume deployment. So now let's execute this command, okay, rollout resume, and right after that, waiting for rollout to finish, 6 out of 10, 8 out of 10, 9 out of 10, and here we'll see that the deployment is also getting updated. All right, so now all the 10 are upgraded to V2, and now when we actually check the output of curl, everything is stabilized on V2. So this is a phenomenal way of taking control of your deployment selectively. So as soon as I saw the number of 6 out of 10 are updated, I hit the pause button. And I'll keep the deployment in that pause mode so that I have a good balance between V1 and V2. Let the traffic flow, monitor your entire deployment, stare at your dashboards, figure out the user experience, get some analysis done, and then decide whether you want to maintain V2 or go back to V1. So as simple as that. So that was a very quick demo of deployments. And as I mentioned earlier, basically deployments give you PaaS-like capabilities. So to summarize stuff that we have done, we created deployment and brought replica sets. We checked the status of deployment, and when we actually ran it in the watch mode, we could see how many of them are available, how many of them are current, how many of them are up to date. And we could update the deployment with just one command without ever touching the YAML file. And we rolled back to an earlier deployment if we didn't like what we deployed. And then we could pause and resume the deployment. So those are the things that we have seen in the demo. So this is how you can emulate PaaS-like capabilities on top of Kubernetes. All right, so it's a very crisp webinar where I introduced the concept, I showed you the demo, and I'm excited to announce the next webinar on 30th May at 9 a.m. Tuesday, and I'll walk you through daemon sets and cron jobs. So typically there are controllers in Kubernetes like replica sets, replication controllers, stateful sets, pet sets, and there is one more concept called a daemon set. A daemon set basically is a container that is scheduled on every node, and it does some very interesting things. So in the next webinar, we'll explore what is a daemon set, what are the use cases, when should you use, and how do you apply your existing Kubernetes skills and concepts to creating daemon sets in Kubernetes. We'll also see how we can schedule jobs through cron jobs, and what are the alternative strategies to using daemon sets and cron jobs. Actually, this fundamental primitive of Kubernetes is enabling some companies like Platform 9 to build serverless layer on top of Kubernetes. So of late, we have seen many serverless platforms emerge on top of Kubernetes. Most of them are based on this concept of daemon set and cron jobs. So in a day or two, we'll update kube.live with the registration page, and you should be able to sign up for this. And all of you are attending this will get an email with a link to the YouTube recording of this webinar and a slide share link with the slide deck. So thanks for joining us. Really appreciate you taking time and supporting us for this webinar series. I hope you found this useful, and I want to get your feedback. I appreciate if you can stay back for a minute and help us with this poll. So how do you rate the overall quality of this webinar? Your feedback is extremely important. I get a lot of emails, but nothing like getting a real-time poll. So appreciate if you can take time and participate. I see only 66% of you participating. Request everyone to take a minute and click on one of those radio buttons to tell me how you like this webinar. All right. Thanks once again, and thank you for supporting us. Do come back for the next webinar in May, and I'm going to walk you through another exciting concept. Have a great week. Thank you.